Hi everyone, so today we're going to pick up where we left off and talk about colligative properties. Please have your notebook, reference table, and something to write with. You can pause the video and grab these things if you don't already have them. And I'd like you to turn to table F for our do now. Which of the following compounds is the least soluble in water? So again, least soluble means it's going to be insoluble or not dissolving in water. So take a moment, pause the video, and try to answer the question. So if you were looking at table F, you should have seen that chloride, acetate, and sulfate ions are on the left-hand side of the table, and they tend to be soluble. Hydroxide, however, is on the right side of the table. It is not bonded with an exception and is insoluble, and that makes it our answer. We're going to talk about colligative properties. This is our last topic for this unit. Starting with an old topic though, electrolytes. So we did a lab a long time ago on electrolytes where we used conductivity probes to test whether or not ionic and covalent solutions would conduct electricity. Electrolytes are ionic compounds or acids that conduct electricity. Again, their ability to conduct electricity comes from the free-moving ions. These free-moving ions allow electrons to move. Electrolytes are going to 100% ionize in water or dissociate in water. Colligative properties are properties that are dependent on the concentration of the solution. So it doesn't really matter what the solute is, it just matters how much solute is in the solution. We're only going to discuss two of these types of properties. There are more than what I'm mentioning, but the first one that you need to know is boiling point elevation. So boiling point elevation is pretty much what it sounds like. The more ions you have in solution, the higher the boiling point of the solution. The second colligative property that you need to know is freezing point depression. So the more ions in solution, the lower the freezing point of the solution. So one of the reasons colligative properties are typically associated with ionic compounds is because when you have an ionic compound, you end up with even more moles of solute in solution because they dissociate. For example, if we take a look, we have sodium chloride. So 1 mole of sodium chloride, I'm looking at the coefficients, dissolves into 1 mole of sodium ions and 1 mole of chloride ions for a total of 2 moles of ions in solution. So because this dissolves into 2 moles of ions of solution, it's going to have a decent impact on the boiling point and freezing point of water. It's going to cause the solvent's freezing point to decrease and boiling point to increase. Another example, so we have calcium bromide. 1 mole of calcium bromide is going to break into 1 mole of calcium ions plus 2 moles of bromide ions for a total of 3 moles of ions in solution. So because this one makes 3 moles of ions in solution, it's going to have an even larger effect on the boiling point and freezing point of water than even sodium chloride did in the last example. Just to contrast those two examples, we have a non-electrolyte. We have sucrose here. Sucrose is not going to break into ions because non-electrolytes are covalent compounds. It's nonmetals bonded to nonmetals. There's no ions involved. So while we only have 1 mole of solute to start with, only 1 mole of solute is dissolved. It's going to have much less impact on the boiling point and freezing points than in the previous two examples. Here's a pretty typical question that you could see in the Regents. Which 1 molar solution has the highest boiling point? So all these solutions have the same concentration, 1 mole. So we're looking for the ionic compound that's going to break down into the most amount of ions. You can do this easily by just counting the subscripts and totaling it up. So for example, A has 1 mole of iron plus 3 moles of chlorine to make a total of 4 moles of solute in solution. Barium chloride is going to make 1 mole of barium plus 2 moles of chloride ions for a total of 3 moles of solute. Calcium chloride is going to break down into 1 mole of calcium ions and 2 moles of chloride ions for a total of 3 moles. And sodium chloride is going to break down into 1 mole of sodium ions and 1 mole of chloride ions for a total of 2 moles of solute. Therefore, the correct answer is going to be A because it makes the most moles of solute in solution. This question is another typical question. It's a little harder than the last one. Which of the following solutions will boil at the highest temperature? So again, we're looking for the most amount of ions in solution. As you can see, all of the answer choices are for sodium chloride, so we don't have to worry about counting ions this time. There's 100 grams of solute in each of these answers, so what we're looking for is the highest concentration. So there's a couple ways to do this. The first one is you can just look at the relationship to amount of solute to amount of solvent. So if we want a high concentration, you're going to need solute to the lowest amount of solvent. Or if you want to actually find the concentration, I found the percent mass of each. And as you can see, D has the highest percent mass.